Hi, so I've gotten a couple questions about this, and so I'm not going to solve the problem here, but I'm going to maybe give some guidance as to how one should think and approach this problem, and this maybe will lend some insight on how to look at some of the other problems in the first half of chapter 3 as well. So what we have here is um, the setup. So we have 10-year-olds who, regardless of gender, follow a normal distribution with average height 54 inches and a standard deviation of 7.5 inches. And so, right away, before I even look at any of these parts, the thing that you should automatically do on your own scratch paper or wherever you're working is draw your curve. Be like, all right, here's my curve, here's 54 here, right? And then my standard deviation is 7.5. All right, great. I got all of that down. And so let's see what they're asking us. And they said, all right, let's just take a look at part D here, since this seems to be the part that's most difficult. And it says find the value k so that 35% of 10-year-olds within k inches of 50 so that 35% of 10-year-olds are within k inches of 54 inches. So 54 is the mean, and that's not a coincidence. And so what does it mean to be within k inches of 54? That means there's some number. Let me switch things up here. Let's go with orange. Say, so over here somewhere, here's 54 plus k. Over here somewhere is 54 minus k, and the claim here is that this area here is, let me check the exact number, is 35%. All right. Now, like I said, first things first, the fact that this problem centers around 54 is not a coincidence. 54 is the very center of our distribution, so that's right there in the middle, right? And then what we should note then is that this distance here is length k, and this distance here is also length k. All right, so that's so over here that's length k, over here that's length k, and they're both the same length, right? This is the same as that. And so that tells me that this 35% really then, because the normal curve is symmetric, is split in half into these two regions. So maybe let's pick some uh, other color, this off red maybe. This then is half of 35 or 17.5%. And let me keep the same color but score it a different way. This right here then is also a 17.5%. All right. And then that leaves, so what's left unknown in this case is these tail ends, right? Well, half the curve is 50%. If these are both 17.5% each, then what should be in our tail lengths? It should be 32.5, right? So let me go ahead, switch my color up again. That should be 32.5%. And that ought to be 32.5% as well, right? And then, well, the question then is, what's k? But I do think we have enough information so that I could solve for that or I could solve for that, right? Like we've got it set up enough, right? We know the mean of the standard deviation or of the normal curve. We know the standard deviation and we know the areas of all of these regions. And that means I can find the values of these points. And once I find those values, I know that the left one is equal to 54 minus k and the right one is equal to 54 plus k. So if I know what the question mark is, then finding k is just a matter of algebra or arithmetic, depending on how you want to look at it. So hopefully that helps clarify this. And this sort of thinking is really what you should do with every single one of these problems about the normal curve. It's really the best way to think about these things. All right, I hope that helps.